users often need to share devices and data, and to communicate with each other. When those users are located in the same department, same floor, even the same building, they can be connected with each other by using a local area network, or LAN. Often those users also need to communicate with departments and offices outside their own area. This can be accomplished efficiently by interconnecting networks. Interconnections can be configured in several ways. Two or more local area networks can be connected directly to each other. A local area network can be connected to a wide area network, such as one using a proprietary networking scheme, like IBM's SNA. And two or more local area networks can be interconnected using wide area networks as intermediaries. This configuration allows the interconnection of multiple networks. There are basically 4 different types of devices used to interconnect networks: repeaters, bridges, routers, and gateways. The method used depends on which layer protocols are the same or different in the networks being interconnected. The repeater is the simplest of the 4 devices and operates at the level of the physical layer. The repeater interconnects network segments of the same type to form a larger network, a network that may exceed the size limit for a single segment. The segments being interconnected must be the same type, and the same protocols must be used for all layers. The repeater's function is a simple one: to receive a message and retransmit or repeat it, regenerating the signal at its original strength. Repeaters are most commonly used with bus-structured network segments. With a ring-structured network, each station acts as a repeater. When there is a need to interconnect separate local area networks, a bridge can be used. The bridge operates at the level of the physical layer and MAC sublayer, and can be used to interconnect networks that use different MAC and physical layer protocols. But the interconnected networks must use the same protocols at the logical link control sublayer and higher. Typically, a bridge is a station that belongs to 2 or more LANs simultaneously. A bridge can also be implemented by a pair of LAN stations connected to a communication facility. The bridge receives all the messages that are sent on each network it connects. But unlike the repeater, the bridge checks the message address and uses it to determine whether or not to transmit the message to the other network. This capability provides a store and forward facility. Messages are temporarily stored in the bridge station and forwarded to another network when appropriate. A bridge can interconnect networks that use different transmission techniques or different medium access control methods. For example, it could interconnect an IEEE 802.3 CSMA-CD network with an IEEE 802.5 token ring network. The bridge must be able to resolve differences in frame format or size. Station addresses on the interconnected networks must be in the same format and must be unique. Multiple bridges can be used to interconnect entire series of networks. While a bridge operates at the MAC sublayer and physical layer, a router operates at the level of the network layer. To be interconnected with a router, networks must use the same protocols at the network layer and higher. A LAN using IEEE Logical Link Control and IEEE 802.3 CSMA-CD Medium Access Control can be connected to a wide area network, as long as the networks are compatible at the network layer and above. A router performs a more complex function than a bridge. The router not only determines whether or not to send a message from one network to another, it also determines the appropriate route to use. In a typical local area network, a message is transmitted to all nodes. A receiving node uses the destination address to determine if it should process the message. In a typical wide area network, a message is sent from one node to another, passing through a series of intermediate nodes on the way from the source node to the destination node. There is usually more than one sequence of nodes, or route, that a message can take. A router determines the next node a message should be sent to and transmits it over the appropriate link to reach that node. This is a function of the network layer. Routers can also be used to interconnect local area networks where there are multiple routes between two networks. There are several methods a router can use to determine which route is appropriate. Routing information can be predefined and stored in routing tables at the router. Or, routers can exchange information on active nodes and links with other routers to develop a network topology map. Or, the sending station can specify the route to use and send it along with the message. Since different routing techniques are used by different network architectures, routers are commonly used to interconnect networks based on the same architecture, or networks from a single vendor. Now that you've seen how routers interconnect networks based on the same network architecture, you'll see how gateways are used to interconnect networks with entirely different architectures. With gateways, different protocols can be used at any of the network layers. The gateway handles any conversions needed to go from one set of protocols to another. This may mean converting message formats, since different networks may use different message formats, sizes, or character codes. It may mean translating addresses, since different networks may use different address structures. And it may include conversion of protocols. When a message is being transmitted, each layer adds control information that specifies the protocols being used and how the message should be processed. A gateway converts the control information so the receiving node can process the message appropriately. Of the four methods, gateways offer the greatest flexibility in interconnection. But they are also the most complex and costly to develop, since they must be able to convert protocols at all levels. Local area networks can be interconnected using a backbone network, a central network with two or more LANs connected to it. Bridges, routers, or gateways can be used to connect to the backbone, depending on the types of networks being connected. Users are attached to the LANs connected to the backbone, not to the backbone LAN itself. The advantages of a backbone network are significant. The attached LANs operate independently, so each can continue to function even if another network or the backbone network fails. The backbone network filters message traffic by forwarding messages only to the networks they are being sent to. And the backbone network can be optimized to provide high bandwidth, transmit longer distances, and be highly reliable. Optical fiber and microwave-based links are often used for a backbone network. Attached networks can be optimized for flexibility and low-cost user connections. You have now seen how networks can be interconnected to form a variety of configurations. And you've seen the methods that are used. Repeaters, which operate at the physical layer, interconnect network segments of the same type to form a larger network. Bridges, which operate at the physical and MAC level, can interconnect networks with different MAC and physical layer protocols and provide a store and forward facility for messages. Routers, operating at the network layer, interconnect networks using the same protocols at the network layer and higher. and route messages to the appropriate destination nodes. Gateways allow different protocols to be used at any of the network layers and handle the required conversions. Gateways, routers, or bridges might be used to connect to a backbone network, a central network with multiple LANs connected to it. Please turn to Mini Course 2 in your personal reference guide and continue your study.